special right shortcut. This only works for special right triangle. So what do we mean when we say a special right triangle? Okay, it has to have two things. It has to be a right triangle first, and then it has to be an isosceles. So that means two sides and two angles are the same for a right triangle. So two sides, and therefore the angles, are congruent. So this doesn't work for any triangle. It only works for an isosceles right triangle. Only isosceles right triangles. So the hardest part of this is to identify if you can or if you cannot use the shortcut. So it's supposed to save you time, and you really don't need a calculator for this part. So again, this only works for isosceles right triangles. So isosceles means two sides, two angles are exactly the same, that two of them are congruent. So for this to work, you're going to have to be able to identify. So it's going to give you one of two things. You're going to have to be able to see that there's two tallies that are the same amount, like these both have one tally. So you know that's isosceles because two sides are the same. Or the other case, you're going to see something like this, where one of them is 45 degrees. If one of them is 45 degrees, the other one, and it's a right triangle, has to also be 45 degrees. Because if you subtract 180 minus 90, you get 90, and 90 minus 45 has to be 45. So even though it may not explicitly say 45 there, you know that has to be 45 because it's a right triangle, okay? So it's going to say 45, 45. It might not give you the other one explicitly, but that's how you know when to use the shortcut. So that's the first and hardest part to this, is to identify if you have a special scenario like this. This will not always work, but this only works when you have an isosceles right triangle. So two tallies, or one of the degrees is 45 and the other one is 90. The other one may not say exactly 45 degrees. So this happens in squares. That's the one that we did together as an example a lot. Okay, so this is how to do it. So remember, in our new unit for right triangles, you have to know when to use it. This is when you use it, and then let me show you how to use it. So you have to identify the given. That's the first thing. You have to figure out, what did they give you? So you're going to be either given the leg or the hypotenuse. The leg is across from 45, or the hypotenuse is across from 90. So if you have the leg, then all you have to do is multiply by square root of 2. If you have the hypotenuse, then you divide by the square root of 2, and that's it. Now, yes, you should simplify it x, y, and z, but other than that, that's all you do. And depending on who you ask, if you divide it by square root of 2, it's more of an accurate answer. Okay, so let's do some examples. So on this one, now we're going to write it. Sometimes you have to simplify, but a lot of times you just write the square root of 2. You don't have to actually multiply it, because we want to keep radicals as they are because they're more precise. So it's kind of like what y'all were doing. So let's do the one that y'all were doing on the board over here. Let's do 2 examples. So this is what y'all had earlier. This was 120, and you were trying to solve for this. These two are the same. Okay, so identify what's given. So when I mean by given, I'm talking about a side length, like a number outside, not the number inside. So the one outside is 120, and it's across from what angle? 90. That box is 90. So because it's across from 90, that means it's the hypotenuse. The given is across from 90. That makes it the hypotenuse. Because it's the hypotenuse, I divide by the square root of 2. So my answer would be 120 divided by the square root of 2. And that is all. That's it. Okay? Does that make sense, everybody? Can you simplify it more? Yes, you can. So let's review. So what's the number given to you on the outside? The number outside is 120. What is a 120 across from? What's this box here mean? 90. So if it's across from 90, I just spilled coffee. That's why I'm making that noise if you're watching this video. It's across from 90. Because it's across from 90, then you divide by the square root of 2. And that's it. So what y'all did was correct. Y'all did that. Y'all just did the extra steps that go with it. So that's why this is a shortcut, because you either divide by square root of 2 or you multiply by the square root of 2. Okay, so in the other one, let's do another example. This was the first one y'all did when y'all had the sides. And the sides, they were 2, but I'm going to make a different number. Let's make it 3. So here, do I have the leg or the hypotenuse? The number on the outside. I have the leg because it's not across from 90, it's across from 45. Even though 45 isn't given to me, I know that this has to be 45 because it's an isosceles. Why? Because I have the 2 tallies. So if it has the 2 tallies, it's going to have to be a 45, 45, 90. So that means it's the leg. Because I have the leg, I multiply. So then it's going to be 3, and multiply means you write it next to square root of 2. And I'm done. That's my answer. So 3 times square root of 2. So again, when you're given the hypotenuse, you divide. When you're given the leg, you multiply. And that is it. Why does that work? Because it's a special shortcut. That means that these 2 sides, if you add them, they're the same thing. So it's 2x squared. Then when you have to simplify that, it's going to always give you this as the result.